Okay, yay, spring break is over. Not really. So quadratic regression, this should go really fast because we just talked about it in class today. So let me get my little marker out. Okay, so when we're doing linear regression, the first thing we did was we entered the data by doing stat edit, and then we got the equation by stat calc 4. 4 was for, and it says this off to the side of the 4, it says linreg. Okay, so our quadratic regression is going to be finding the parabola of best fit, right? These are best fit lines because it's possible that there are multiple lines that would approximate the data that you put into stat edit, but you want the one that fits the best. And for quadratic, it's going to be a parabola, and for linear, it's going to be a line. And you're going to, when we get down to the problems, we're going to work some problems where you're going to have to use your judgment to decide which one is the best fit. So here we are. Ah, I don't want to do that. Go away. Go. Yeah. Okay, so the first thing we did is stat edit L1 and L2, and that's where we enter the data. L1 is X, L2 is Y. Okay, and then we're going to want to look at the data just to make sure we put it in correctly. And we might want to determine if it looks like it's linear or quadratic equations. So to look at the data, you have to turn on plot 1, which is your second y equals. And then if you zoom 9, it will put all that data on a graph that you can see it, and it will give you basically the graph of best fit, so you can see all the points you put in, there's nothing missing. After you look at it and go, oh, it's obviously a line, or it's obviously a parabola, then you're going to do your stat calc quad reg, which is number 5, and then you're going to do enter, and this is going to find the equation of best fit. Okay, and we plug it into y equals. You can copy down the equation and put it into y equals, but you don't have to, because when you get to after you do this, if you find where it says store, and it says something like this afterwards, then that's where you do vars, y vars, enter, enter, and it will store your equation in y1. So when you're finished with that and you actually get the equation, you can do zoom 9 or graph, and you can look at your line related to your data points and see that it is a line of good fit or not. So with that being said, let's look at our calculator. Now I've got some data in my calculator that I already had in there. And so if I go to stat edit, I have these points already in. If you want to write them down and put them in your calculator, or you don't even have to write them down. If you want to turn on your calculator and put those in and follow along, that would be great. But since I already have in these points, and I have no idea if they're supposed to be linear or quadratic, but I'm going to do both equations. I'm going to find a line of best fit and a parabola of best fit, or a quadratic of best fit, and I'm going to show you the difference, and that sometimes it's hard to tell. So the first thing I'm going to do is I'm going to do stat, calc, and I'm going to do number 4, which is linreg. I'm going to hit enter, and then I'm going to hit enter and enter and enter, and then when I get to store, vars, yvars, enter for function, enter for y1, there's my y1, then I'm going to hit enter and calculate. Okay, here's my formula, and it's -5x minus 2. So that's my linreg. Oh, I forgot to show you my data before. Okay, so let's go to y equals. And my plot 1 is turned on up here. So see where it's blinking up there at the top left? If that's dark, my plot is turned on. So if I go zoom 9, there's my points, the blue squares, and then my line that I made is right there in blue, and it looks like, meh, not a great fit, but not bad. Okay, so now let's go back to stat calc, and let's do the quadratic. So let's go down to number 5. Okay, and let's have it do the quadratic. I'm going to hit enter. Okay, L1 and L2. Now when I do my whatever, I'm going to do vars, yvars, enter. But I'm going to go down to y2 so that it will store this one in y2, and I can look at my line and my parabola at the same time. So here's my equation that already also looks like a pretty good equation. -1 squared minus 5x, -1x squared minus 5x, no 0. Okay, so now I'm going to hit graph. There's my points, there's my line, and there's my parabola. So actually, the parabola looks pretty good compared to the line. So if I had looked at that data before I drew my parabola and my line, I probably would have said it's a pretty good line. Now that I'm looking at my equations graph, I'm thinking, oh, that was probably a parabola. So I would, on my paper, wherever I'm doing this, would probably have written that it was a quadratic equation. And I would write down my equation, which is in y equals. I would write down y2, -1 x squared plus -5x plus 0 as my equation, because that seems to be a way better fit. So I have a line of best fit, which happens to be my parabola, a quadratic, and I have the formula or the equation because it's already in y2. Okay, so now let's do this with some of the data on our paper. So number 1, I'm going to go to stat, edit, and I'm going to clear these out. And remember, when you clear them out, you go up to the L2 so it's highlighted, clear, enter, and it clears everything. And then I'm going to go over to L1, clear, enter. Remember, if you hit delete, it's going to take away your L1 or your L2, and you're going to have to reset your calculator. So I'm putting in for my x values, -4, -1, 3, 5, 7, 9, 10. 3, 5, 7, 9, 10. Okay. And then my y values I'm going to put in 2, 3, 5, 7, 11, 14, 18. Okay, and just looking at those, they're both increasing. It looks like it's increasing by 2, by 2, by 2. And then gets a little bit by 3, by 4. It doesn't look like it's going to be a perfect line, but I'm not really sure. So I'm going to do zoom 9 because zoom, well, first of all, I'm going to go to y equals. My plot is on. I'm going to go ahead and clear out my equations. My plot 1 is still on because it's dark up there in the top left corner. So I'm going to do zoom 9, and it's going to make a graph. All my data points that I put in are right there. Ooh, I'm thinking it's a parabola, a quadratic, and not a line. So I'm going to go ahead and circle quadratic because I'm pretty sure that's what it is. So let's go stat, calc, number 5, enter. I'm going to go down to store, vars, y vars, enter, enter, calculate. I'm going to write down my equation. I'm going to round to the nearest hundredths, which is what the directions say. So I'm going to write down y equals 0.10 x squared plus 0.47x plus 2.67. Okay, so I wrote that down on my paper. Now I'm going to look at my graph and see what a good fit that is. That's a pretty good fit. I kind of like that. Just for fun, let's go back to our stat calc and let's do a line just to see how good of a fit or not it is. And you don't have to, well, it's good practice in your calculator. Do this in your calculator. Okay, so when I do my vars, y vars function, I'm going to go to y2 because I want that in a different place. Okay, so my equation is 1.07x plus 4.1. Let's look at the graph. There's my nice parabola. What does the line look like? Ew. See, that is not a really good fit if you look at that line. And I definitely think the quadratic is the right equation to use. Okay, so let's do number 2. So I'm going to go to my y equals, and I'm going to hit clear. I'm going to leave my plot on. Stat, edit. I'm going to go up to the L2, clear, enter. Over to L1, clear, enter. So now I'm going to put in my data for number 2. So I have 5, 8, 11, 13, 19, 21, 25, 27,